Hi, 171. I'm going to cover some quick information, review material about sections 8.3 and 8.6. These are found in the appendix of the textbook, so in the back of the textbook. If you're using the ebook, just make sure you go to table of contents, and it is in the bottom in appendix. So the first thing we're going to talk about is factoring. So there was one special type of factoring that we had, which was difference of squares. So with a difference of squares, we said this was a squared minus b squared factored into a plus b, a minus b. So as an example, if we had something of the form x squared minus 16, then it's a difference of two squares, because that's the same thing as x squared minus 4 squared. 16 squared is, or 4 squared is 16, so this factors into x plus 4, x minus 4. So this would be a difference of squares. Now, as a little one that's a little different than that, we could say, let's go backwards. So what if I had the expression x plus 2 minus m, and then quantity x plus 2 plus m. So two things to note here. One is that we have this first piece, they are the same. The last piece is the same. The only thing that's the difference between them is in the middles here of the two pieces, one's plus and one minus. So this looks almost like this with a lot more variables in a number. So what we would do is we could actually re-express this as going backwards. So the first piece is a, that's going to be the x plus 2 piece. So that's going to give me x plus 2 squared minus the b piece. And the b piece in this case is the m. So that's going to be minus the m squared. And you could go even further and expand this out, which would give you x squared plus 4x plus 4 minus m squared. And this would be the result of multiplying that out using the difference of squares formula. Another type of factorization is the sum and difference of cubes. Now when it comes to squares, as we had, you can only factor the difference like we saw. When it comes to cubes, I can actually do the sum or the difference. So here's what those formulas look like. So you can have the sum or difference of cubes. So if we had a cubed plus b cubed, this is going to factor into two pieces. The first piece is just going to be your a and your b. So a, b. The other pieces are going to be the first term squared, so a squared. Then you're going to have a term here that's going to be the product of these two, so a times b, and then the square of the second term is the last term in the bigger parentheses. Now notice I've left some blanks because we need to know if this is pluses or minuses. And so there's one way to remember this, and this is SOAP, all right? This stands for same, opposite, and these together are always positive. So this is the same sign, because that's the first letter in SOAP. The second sign is the opposite sign, so the opposite of plus. And this last sign is always positive. So that's going to be that factorization. So let's look at that using the difference. So a cubed minus b cubed. I always think about a little one and a little bit bigger one when I do different or sum and difference of cubes. Again, you still got your a, your b, your a squared, your ab, and your b squared. This is always the same. ab, a squared, ab, b squared. The thing that changes is the sign. So remember SOAP, it's going to be the same sign. So the sign was negative, so this is the same sign. This is the opposite sign. The opposite of negative is positive. And AP from SOAP is always positive. So this would be the difference of cubes. And here are your two formulas for factoring sums and difference of cubes. So as an example, let's say we wanted to factor let's do 8x cubed minus 27y cubed. This one's a little more complicated and different than what we've done before, but I think it's good practice. Notice everything here is a perfect cube because 8 is 2 cubed, x cubed is x cubed, 27 is 3 cubed, and y cubed. So we can actually rewrite this as, this is going to be 2x cubed minus, and this is going to be 3y quantity cubed. And so that is a minus one, so we're going to use the second formula here to do the factorization. So we're going to have a little parentheses and a little bit bigger parentheses. It tells me to use the first term, which is 2x, minus, because it's the same sign, the second term, 3y, square the first term, so 2x quantity squared. I'm going to write everything out right now. The opposite sign, so that's plus. Then it says to multiply the two pieces. So we're going to multiply 2x and 3y. And then the same, or sorry, always positive, and then cube the second term. Sorry, square the second term. Now this is a lot of parentheses. We can clean this up. To do that, we would say 2x minus 3y. That's going to give me 4x squared plus 6xy plus 9y squared. And this is going to give me the factorization for that difference of cubes. If we were to have positive or plus, the only thing about this that's going to change is the signs. The letters and the numbers are going to be in the same place. The signage is the only thing that's going to change for this particular factorization. And so that is the sum or difference of cubes. So now I want to talk about factor by grouping. We usually use factor by grouping when we have 4 terms and there seems to be a pattern. So for example, I see that there's a common factor between these two pieces and a common factor between these two pieces. So what I usually do is think about splitting this straight down the middle so that this is something I'm going to factor the left and I'm going to factor the right. So let's do that process. The greatest common factor on the left-hand side of the bar is an x squared. So they both have an x squared in common. That's the greatest thing they have in common. So when I factor that out, I get 3x plus 1. That was what I'm left with. Now over here, what they have in common is not only a 5, but they're also both negative. So I can factor out a negative 5, And so when I bring out negative 5 from there, that's going to leave me with positive 3x, and bring out that negative leaves me with positive 1. Now when I do factor by grouping, what I'm looking for to see if I've got the correct answer is if the thing in parentheses, the term in parentheses, they're equivalent. I want them to be equivalent to make sure that I've done factor by grouping correctly. So that is my new factor that I'm going to pull out to the very front. And in this other parentheses are going to be the two factors that were left over from the beginning. So x squared minus 5. Now at this point in the course, we can't go any further with x squared minus 5. So we have to leave it at that. Is our answer for factor by grouping. Now I do want to make a side note. If I would have factored this out and got something of the form 3x plus 1 x squared minus 9. Okay, if I would have gotten something that looks like that, then this could factor again. This piece right here, x squared minus 9, is a difference of squares, and it can factor once more. So I would have to factor that into 3x plus 1, x minus 3, x plus 3. So notice the difference. 5 is not a perfect square number, so this does not factor, as where 9 is. This needs to go one more step.